Okay, so let us do EM induction CFQs. So the first CFQ given here is, suppose a conductor, okay, is moving in a magnetic field. Okay, so we know that an EMF will be developed across it. Now suppose here a resistance is placed. Okay, so what will be the force needed to pull this conductor? Okay, fine. Okay, so let us do it like this. The current will be E epsilon by R, induced EMF by resistance. Now epsilon is BLV by R. So obviously a Lorentz force will act like this, Fm. Okay, so the equation of motion will be mass into acceleration is F minus Fm. So it will be like m dv dt is F minus Fm is Bill. Okay, now put the value of I. We will get F minus B BLV by R into L. So m dv dt will be F minus B square L square by R into V. So if we write it like this, dv F minus B square L square by R into V, and let us write this 1 by m dt. Now let's integrate both sides, 0 to t, 0 to v. Then we can write it like this, log F minus B square L square by R V 0 to V 1 by m t, log upper limit if we put F minus B square L square by R V, and if we put the lower limit minus log V এর জায়গায় 0 বসালে log F, তাহলে log A minus log B is log A by B. Okay, so we'll do it like this. And also I've missed something. Minus R by B square by L square integration formula. Okay, it will come here. So we can write it like this, log now distribute it 1 minus B square L square by FR into V, and it will be minus B square L square by MR into T. So it will be, V will be like FR by B square L square and 1 minus e to the power minus B square L square by MR into T. Okay, so after a long time, okay, so V will reach a constant value known as the terminal velocity, Fr by B square L square. Okay, so it is the graph will be like this. Okay, velocity versus time graph will be like this of this conducting rod. Now if a capacitor is placed in place of the resistor, the same problem. Okay, it is given a force F. Now what will happen? Okay, so if it is C and the charge is Q minus Q, then obviously the EMF developed across it will be epsilon. So Q will be C epsilon. Q is CV, right? So Q is C dLV. So if I do dq dt, so I get the charging current. Okay, so it is CBL dV dt. L is the length of this rod, so dq dt is I, so I becomes CBL dV dt is A. Alright, clear? So now this charging current also flows through this conductor, and a Lorentz force will act on it on the opposite side. Okay, so here also F minus Fm is Ma. Now Fm is Bill, right? So F minus I এর ভ্যালু পুট করলে I get CBLA into L is MA, so it will be F, এটা এই সাইডে গেলে হবে M plus B square L square C into A. Okay, so the acceleration of the rod in this case will be given by the force by M plus B square L square C. Okay, fine. So this term will act as an extra mass to this rod. The mass of this rod is M, but this term will act as an extra mass. Okay, the rod will be harder to move. You have to pull it by the force F. Because of this Lorentz force, against this Lorentz force you have to pull it, right? Clear? Okay, and so here also this work done by you will be spent as it will one part of the work done by the external agent will be stored as the electrostatic energy in the capacitor as it is being charged, and the other part will be dissipated across the resistance of the rod. Okay, here in the first case the external, we have already seen this case that the external work done is being dissipated across the resistance R. There is no question of storage of energy. Now in the third case, let this be an inductor L. Okay, now an impulse is given to it, okay, on this conductor. So what will happen? On this conducting rod an impulse is given to it. Okay, now what will happen here? See, let At any instant the velocity of the conductor is v, then the EMF will be BLV, right? Now this BLV, the EMF will be equal to the back EMF stored in the ইন্ডাক্টর, রাইট? এই ইন্ডাক্টরটা মধ্যে যে ব্যাক ইএমএফ তার সাথে ইকুয়াল হবে এইটা, রাইট? সো ইট উইল বি অ্যাকচুয়ালি ইকুয়াল টু এল ডিআই ডিটি। ওকে, সো minus L di dt will be BLV. Alright, now you tell me minus L di dt. Now what is V? Suppose this rod is displaced by an amount dx. Okay, so the in time dt, so the velocity, instantaneous velocity is dx by dt. Okay, so it would become minus L di is BL dx, right? So if you integrate it, you will get minus Li is BLX, so I will be minus BLX by capital L, right? Okay, so here you see as soon as a current starts to pass, because an EMF has been induced, it is a closed loop, a current has to pass through it. Okay, as soon as the current will pass, there will act a Lorentz force, because a current conductor in a magnetic field will experience a Lorentz force. Now that Lorentz force will act actually as a restoring force to the conducting rod. Okay, so here mass m into acceleration d2x dt2 will be the force Fm. Okay, clear? Fine. নাও এবার এখানটায় একটা জিনিস দেখো, আমি কিন্তু রেস্টোরিং ফোর্সে আর মাইনাস এম এ লিখিনি, কারণ অলরেডি আই হ্যাভ গিভেন আ মাইনাস ইয়ার। ওকে, আমি তো অলরেডি এখানে মাইনাসটা দিয়ে দিয়েছি, তাই দুবার নেগেটিভ দিলে আর কি অপোজিট মিনিং হয়ে যাবে। অলরেডি আমি ব্যাক ইএমএফ এর কেসটা দিয়ে বুঝিয়ে দিয়েছি যে এফএম উইল অ্যাক্ট লাইক দিস, উইল অ্যাক্ট ইন দিস ডিরেকশন। ওকে, ক্লিয়ার? সো ইট ইজ bill. So m d2x dt2 will be, so I have just written mass into acceleration is Fm, b into minus blx by L into L. So I get d2x dt2 minus টা এদিকে প্লাস b square L square by ml into x is 0. So this becomes simple harmonic motion SHM. Okay, so with an angular velocity omega being BL by root ml. Okay, and time period is 2 pi by omega, that is 2 pi root ml root ml by BL. Okay, fine. So this conducting rod will execute a simple harmonic motion of this time period or frequency. Clear? All right. Okay, here you observe one thing, as we have written minus L di dt is BLV. Okay, the induced EMF. So if we multiply it by I on both sides, then what we'll get? BILV. Now what is BIL? It is Fm. Fm into V. Now what is Fm? Fm equals m into A, m dv dt, m into A. Okay, So let us write m dv dt into v, right? Now if you multiply it by 2 on both sides, what we will get? Minus L into 2I di dt m into 2v dv dt. So you can write it like d dt of I square, and okay, you don't have to multiply it by 2. You also multiply it by half on both sides. Okay, fine. So minus half L. So if you multiply it by 2 and half, it's all right? So it is d dt of I square, and it is half m d dt of v square, right? Fine. So if you take this term on this side, then you get d dt of half L I square plus half m v square is 0. So half L I square plus half m v square is a constant. So the magnetic energy stored in the inductor and the kinetic energy of the rod, the sum of these two is a constant. Okay. And it is very expected, as the conducting rod is executing simple harmonic motion, the total energy has to be constant of the oscillation. Fine, clear. Now let us do another problem. If now the same type problem, if now a cell is connected of EMF epsilon and the conducting rod is moving. Okay, let the conducting rod has a resistance R. Okay, it has a length, say L, and it has a resistance R. Fine, clear. Now you tell me one thing. Now say this is, what will be I in this case? Can you tell me? See, when the conductor is moving in magnetic field, there will be an EMF induced across the conductor. Now this induced EMF is a back EMF. It will oppose the battery EMF. So the net EMF will be epsilon minus epsilon induced by the resistance R. The rod's resistance is the resistance of the loop, right? So it will be like epsilon minus BLV by R. Okay, clear. Now the FM, when a current will pass through the conducting rod, a magnetic force, Lorentz magnetic force will act on it. So Fm will becomes m dv dt, right? Okay, so Fm is Bill, clear. So here it will come out to be m dv dt is B into epsilon minus BLV by R into L. Alright, so it will be like dV by epsilon minus BLV, and here it will be BL by MR into dt. Now integrate both sides, 0 to t, 0 to v. So what you will get here is ln epsilon minus BLV, you will get minus 1 by BL, okay, and it will be BL by MR into T. So it will be this 0 to V. So upper limit ln epsilon minus BLV minus lower limit, put 0 in place of V, you will get ln epsilon only. So ln A minus ln B is ln A by B. It is minus B square L square by MR into T. So if you distribute it 1 minus BLV by epsilon, you get e to the power log ওদিকে চলে গেলে অ্যান্টি লগ e to the power this by mr into t. So you get v as epsilon by bl 1 minus e to the power minus b square l square by mr into t. Okay, so here also you are getting a graph, vt graph like this. Okay, so after some time the velocity is being constant. After t tends to infinity, the velocity becoming the terminal velocity, it is a constant. Okay, so Vt is basically here epsilon by Bl. Okay, fine. Alright, so at the first case, the terminal velocity was Fr by B square L square. Here it is epsilon by Bl. Alright, clear? So it is the impulse given to the rod